Linear differential equation part 2, oscillation and wave. We will examine the one special case of linear differential equation, which is very common in physics. I hope you watched the previous video, linear differential equation, how to solve it before this. Okay, we consider the three-dimensional coordinate R, and this is one linear differential equation. So how we solve it? For the y coordinate, we look at use the d operand. This was explained in the first part of the video. So d squared plus n squared is 0. And what's happened is, if n is imaginary number, okay, then we can solve d equals lambda or negative lambda, which is negative in or in. So solution will be this form, and since we have an Euler's formula, we plug in, then we'll get the cosine and sine combination, which is just simple sine with some phase. Okay, so x and y also get that, and that's a solution of the differential equation, and that's the oscillation. Okay, so if period t, frequency f, we can calculate n is 2 pi over t. So I don't know if you had ever used the oscilloscope. The oscilloscope takes the input from x and y coordinate, and if you have the ratio n1 to n2 is 1, you see this on the oscilloscope. If the ratio is 2, then you see this. If it's between 1 and 2, then screen keep moving around, but exact 2, it's gonna settle into this kind of display. If 3, then it will be like this. Okay, between 2 and 3, screen keep moving because there's no stable point. Okay, now oscillation with attenuation. Attenuation term here is gonna give the attenuation of the oscillation. Okay, so initially we assume this is a simple solution, c is a constant. Okay, then this is a condition for the solution. Now this is a common technique to find the solution for differential equation. We assume c is not really constant but a function of t, so we get this. Okay, so c is something to do with differential equation solution, and solution is up to n squared minus lambda square square root. Okay, so what's happened is, when n is larger than lambda, the solution will be attenuating sine form. This attenuation is expressed by this. Okay, when n is smaller than lambda, then it's simply monotonous damping function. Now when n is equal to lambda, what's happened is it will have single hump and go monotonous. Okay, so that's a kind of function we get as a solution. Now, what is the difference between wave and oscillation? The wave is like single point is oscillating, right? Next point is oscillating, next point is oscillating. This oscillation is propagated by Huygens principle, right? I hope you learned that in the physics. So it's look like animation effect. For human eyes, this hump is moving, Actually, it's not moving, it's just every part is oscillating. Okay, so basically wave is oscillation with phase. So next point is slightly different phase than this, and next point is slightly less different phase than this. So there is a phase depend on the location. So this is x. You have this phase come into the equation. So that's going to be the wave equation. So without this, you look at a single point, x is fixed. It's simply oscillation. But as x change, the phase change, that's the wave. Okay? So wave is oscillation of multiple point with phase difference. If phase is not coordinated well, it doesn't look like oscillation. It's going to be random oscillation, like beans jumping up and down in a playing field, and that doesn't look like a wave. Okay, so wave has two variables, time and the location. Location gives a phase. Okay, so when you, what kind of equation is going to create the wave? Well, it's not only t, but partial derivatives of x. So this is going to be the wave differential equation. So you have a multi-variable. It's going to be partial derivatives, and the 3D wave goes xyz like this, and this delta means divergent gradient u. Okay, you get this when you learn the electromagnetic theory. The microwave, electromagnetic wave, is exactly this form. Now, solution to this equation is two-part: location parameter and time parameters, u, x, t. Okay, and the sea water is known to have this kind of function. It's not exactly a clean sine wave. It's depend on the depths and the gravity acceleration, and k is wave number. So you can do a little bit more research on sea wave, ocean wave. When it's come to the wave, there is a particular characteristic we go through in the physics. It's a wave interference and standing wave. What is a standing wave? And 3D wave propagation, how the wave propagates in 3D dimension. Okay, so those are physics subject, but basic equation is this guy. Okay, so this is a basic wave and oscillation video. I hope you enjoyed listening, and please check other videos. We have more interesting videos, and if you like, please click subscribe. Thank you.